We're talking in Chapter 15 about this autonomic nervous system. And in this autonomic nervous system, we've talked about how we're going to have the sympathetic division and the parasympathetic division. And at this point, we've been talking about the sympathetic division. We're finding out that it's not very sympathetic, that it's the system that ramps us up. It's the system that gets us prepared for the fight or flight. So what we're finding is that this system is going to have to work. Even though when we look at the nervous system, the way that the information is going to travel, it's going to travel by way of our spinal nerves. And in this sympathetic division, we've learned that there are two fibers. We have to have one that is termed pre-ganglionic, one that is post-ganglionic. We've also learned that in this division, we're going to find chain ganglia that exist just outside of that central nervous system, and in some of the passage of information, this pre-fiber will synapse in the ganglion. But in some of this information, we go to an accessory ganglion, and then it synapses and travels the rest of the way to its target organ. Now, in one that I pointed out was the adrenal gland. The medulla of the adrenal gland is actually nervous tissue. And therefore, when we look at this setup that we have for the sympathetic division, the setup that we have, it's going to synapse directly in this medulla. All right? So if we see what's happening with our sympathetic division, the one that's gearing us up, the fight or flight, this impulse, okay, travels and synapses directly on cells in the medulla of the adrenal gland. All right? The reason for that, can you think of any type of hormone associated with this gearing up for the fight or flight that can be associated with that adrenal gland? Adrenaline. Can you think of anything else?
The norepinephrine.
Now, what we're going to find with the norepinephrine and the epinephrine, it's going to be a precursor for the epinephrine. So what we end up thinking about as those adrenaline hormones, they're kind of like meeting or making that epinephrine that we think about. And then, of course, we've got the adrenaline. Can you think of anything else? Cortisol. All right? So we got a lot of things that when that synapse occurs in the medulla of the adrenal gland, that sets this, it's like it's setting this activity in motion, generating these hormones. And once again, we're going to find out, because when we get into the endocrine system, that the hormones exist longer in the bloodstream. That's why they have such a lasting effect. So in the sympathetic division, the way that the information is going to travel, if we have to use pathways given to us by the spinal nerves and in association with the spinal cord, okay, when we first look at the pathways, it looks like it's a little difficult. But now, something to remember. When we look at a cross-section of the spinal cord, you guys remember how we have the little butterfly, okay? We've got the white matter, we've got the gray matter. Then do you remember us mentioning little columns over here on the lateral side? It's the lateral side that is responsible for integrating information from the ANS. So the lateral side of the spinal cord is responsible for the information passing within ANS. So those spots, those areas are going to have the tracts, T-R-A-C-T. And if you remember, we have tracts that move information up and responses down. So the lateral side, but when we look at the structure, all right, when we look at the structure, we still have to deal with the spinal nerve that's exiting. Okay, so if we're having to travel a path that is along with the spinal nerves, but the spinal nerves meet skeletal muscle. So now, with our structure, we need to have the information go to our viscera. So we gotta have some branching occur. Is everybody with me? Now, we have those pre-ganglionic fibers, the post-ganglionic fibers. Those pre-ganglionic fibers, now remember, they're going to travel by way of that spinal nerve to a ganglion. But we had two areas for a ganglion. We had that chain ganglia that's outside of the nervous system, and those accessory ganglia. Yes, there's 1, 2, 3. All right? Now, the post fiber has got to travel to our target. So, what we're going to say is that on the spinal nerve, we're going to have some rami, a ramus. What have we learned about the term ramus? Because we've mentioned this before. It's a projection. It's an extension off of something. All right? So if we've got this extension off, that is going to give us the ability for the impulses, the action potentials for the autonomic nervous system in the sympathetic division to travel to their target organ. So this structure that we now have by way of the spinal nerves is going to give us the ability for the sympathetic fibers to travel to their target organ.
So the post-mnemonics usually know.
The pre. Now, hang with me, Lucy. Okay? Because here's what I want you to do. The handout. Does everybody have the handout that I gave you? Take out the one that looks like this. Study it for a second. Start at number 1. Move to number 2. Move to number 3. Did you get that?
Yes, ma'am.
Then look at the structure that's being represented. Okay. Here we go. Follow me. Follow with the structure. Okay? Because this is the only way I can understand it. So it's the only way I can teach it to you. All right? Let's recognize what we're looking at. We're looking at a cross-section of a spinal cord. White matter, gray matter. On the lateral side, like I've said, is where the ANS deals or comes from. Okay? So, note my lateral side. Is everybody with me? Now, if I look at what they're trying to represent here, okay? Soma, body. Think about the structure of a neuron. Dendrite, cell body, axon, terminal ends. Okay? So now they're trying to represent, see the little circle right here? Circle, circle, circle. I got 4. All right? So this is telling me there are 4 that an impulse, an action potential of the sympathetic division can travel 1 of 4 available pathways. Now, this is my body, the soma. These are my axons. Now let's trace the pathways. Because if this is my structure, the cross-section of my spinal cord, do you guys remember the anterior and posterior? Okay? And then extending out to be a spinal nerve. This is representing the chain ganglia that's existing just outside of that central nervous system. Because the spinal nerve, the impulse goes to something with the skeletal muscle. I now need my impulse to travel to viscera. So I need it to take a different pathway. So if I look at what's happening, let's just trace the axons.